This is the first of two videos on showing how to solve problems involving converging and diverging lenses. We'll be drawing two rays, one which will follow a ray, an incident ray which is parallel, which will then travel through the principal focus. Then we will do through the optical center as the second one. There's a third rule involving the secondary focus, but we are going to bypass that one because these first two are easier and better for learning. So the first ray that we're going to be doing, first rule, from the tip of the object, that's where the light's going to be traveling from. It's going to travel to the middle of the lens. So that's the portion that bisects or divides the lens in half. Add your arrow to indicate the path of the incident ray. The second ray will then travel from the midpoint through the optical center, through the principal focus. You'll notice how I position my pen or pencil by putting it over the dot first to make sure that the spacing is right. It just helps to make sure that the line that you're going to be drawing is more accurate and that everything's centered. Even though I did that, this is a little bit high on the focus, which can alter a bit of the positioning of the ray. So the second one, from the tip of the pencil through the optical center. So the second ray is going to travel like this. There's the incident ray. There is the refracted ray. These two rays meet up here, which means that the image is going to be located roughly about this location. Now, these drawings are used to estimate where an object will be. Later on, we'll go through a tutorial on how to actually calculate the exact distance that the object would end up, that the image would end up appearing. The size, attitude, location, and type for this image are smaller. Attitude is inverted. The location is between F and 2F. And the type of image is a real image because the rays really do meet up. So the second problem, for this we will do a incident ray that runs parallel to the principal axis. Second one is going to go through the focus, the principal focus. There's our two rays, incident and refracted. We're now going to travel through the optical center for the second ray. And if you draw it nicely and perfectly, the meetup point should be directly below 2F. You can see, although my rays are pretty well drawn, that the meetup point is a little bit off center from 2F. But this is where it should technically be. It's a pretty good drawing for this one. On tests, I personally don't normally include it at that location in problems involving 2F, because it's really hard to get a perfect ray if you go off a little bit through the center of if you don't go through the center of the circles for the focus or the optical center, it throws things off. The size is supposed to be the same. The attitude is inverted. Again, location is between, it's at 2F. And the type of image is real because, again, the rays really do meet up. The final problem we're going to work through for this introductory set, because they are a little more straightforward, a little easier. Incident ray, go through the focus, principal focus. That's our first set of rays. Second ones we're going to go through. I'm going to have to extend this line because it doesn't look like it's actually going to meet up otherwise. That extends a little bit off of the paper or the space. Extend this one to see where they do meet up. So the image will extend the principal focus is now going to be here. So this is going to be a magnified version of the pencil. So the size is larger. The attitude is inverted. The location is beyond 2F, beyond 2F. And the type of the image is, again, real. So that's the first three problems.